So, hello Year 12. For the last video on topic 5, formulae, equations and amounts of substance, and my last video before Easter. We'll resume after the Easter holidays with topic 8, Hess cycles, energetics. I'm going to set you some work for the lesson today. It's about 42 marks from the 2018 past paper, paper 1. That's your work for the lesson today. I'll put the mark scheme on at some point next week. If you choose to do the rest of the questions on that paper, that's totally up to you, but I am not setting you Easter work in line with the policies coming through from Mr. Young. Just a reminder, last week 12D were definitely the stragglers in terms of their quiz responses. So let's see if anything has changed with the second set of questions that were hopefully due in by 9 AM this morning. Okay, well, I think the first thing we can say is that there's a couple of groups where the completion rate is really low. And is it fair to really award 12B any credibility if only 50% of them have handed in? Ditto 12A, 57%, not particularly impressive. So therefore, I want to just highlight 12E. Well done 12E. 9 out of 10 of you handed it in on time by 9 AM this morning, and therefore definitely 3 cheers for you. But 12D, pulling it out of the bag, not only did they have a reasonable, almost 70% submission rate, but they also got the highest score out of any group, 93%. So very well done 12D, pulling it out the bag and showing us what you can really do. Well done to you. Right, so we're going to have a look at the 12 or 13 worst answered questions from that second set of questions that I submitted to you. And these are questions that students always struggle with, and I really don't know why they do, because there's no need to struggle with it. So if we look at question 15, how many ions are in 284 grams of sodium sulfate? Right, first thing, moles of sodium sulfate is mass over MR, 284 divided by 142, which is 2 moles. And that is the number of number of moles of Na2SO4. So how many particles do we have? Well, we just times that by Avogadro's number, 6 times 10 to the 23, which gives us 1.2 times 10 to the 24. And that's how many particles of Na2SO4 we have. This is where you just need to know your GCSE chemistry, that a particle of Na2SO4, sodium sulfate, is 2 Na plus ions and an SO4 2 minus ion. There are 3 ions, therefore if there's that number of particles, the number of ions we times by 3 to get 3.6 times 10 to the 24, and answer C there. Similar idea here, how many moles of ions are present in 30 centimetres cubed of this? Well, first thing, moles is concentration times volume, which equals 0.025 times 30 over 1,000. And that equals, if I look at my calculator, 0.025 times 30 divided by 1,000 is 0.00075. But that's the number of moles of barium hydroxide. Okay, that's the number of moles of that. We want to know the number of moles of ions. Well, each barium hydroxide particle contains a Ba2 plus ion and 2 hydroxide ions, 3 ions in total. Therefore, the number of moles of ions is that number times 3, which is 0.00225. So again, the answer is C. Right, this is a question about diluting down. How much water do we need to add? Well, there are a couple of ways to do this, and let's go with the dilution method first. So we are diluting something that is 1 times 10 to the minus 2. We're diluting it down to 5 times 10 to the minus 4. And if I work out what that dilution factor is, 1 times 10 to the minus 2 divided by 5 times 10 to the minus 4. That's a dilution factor of 20 times dilution. And that means that the volume must go up 20 times. So the volume must go up from 10 centimetres cubed up to 200 centimetres cubed. Now, be careful here, that is the final volume, so we need to add 190 centimetres cubed. That's 3 there. If you're not quite happy with dilution factors, you could have worked out the number of moles in the original solution, which is 1 times 10 to the minus 2 times 10 over 1,000. That's the number of moles in the original solution. And then you could say, well, you know there's going to be that same number of moles in, well, let me just work this out. So 1 times 10 to the minus 2 times 10 divided by 1,000 is 0.0001 moles, and therefore you want the volume. Moles is concentration times volume, so volume is moles over concentration, which equals 0.0001 divided by 5 times 10 to the minus 4 divided by 5 times 10 to the minus 4 gives you a volume of 0.2 decimeters cubed, or 200 centimeters cubed, and therefore you do the same thing as above. You need to add 190 centimeters cubed. I find the dilution method much easier to work out, but you could do it by working the number of moles and working out what the final volume must be using moles equals concentration times volume. A lot of people getting stuck here on this question. Calcium carbonate reacts with dilute nitric acid as follows. 0.5 moles of calcium carbonate was added to a solution containing 0.008 moles of nitric acid. Right, so 0.005 moles of calcium carbonate would need 0.10 moles of nitric acid. Okay, so there's not quite enough there. So if we've got 0.08 moles of nitric acid, then we know that 0.04 moles of calcium carbonate would react. That would form 0.04 moles of that, 0.04 moles of that, and 0.04 moles of that. So let's have a look at this. 0.05 moles of carbon dioxide is produced. No, because not all the calcium carbonate reacts. 0.8 mole of calcium nitrate is produced. No, it's not. Calcium carbonate is in excess by 0.01 mole. That is true. Nitric acid is in excess by 0.03 moles. No, nitric acid is the limiting reagent. So it's that calcium carbonate is in excess by 0.01 moles. Hydrogen is manufactured using this reaction. You might recognise this from GCSE. It's the one that feeds into the Haber process. The percentage yield of hydrogen in the process is 90%. The mass of hydrogen in tonnes, which can be produced from 160 tonnes of methane. Right, so we've got moles of methane is mass 160 million grams divided by 16, which is 10 million moles. That's a 1-to-1 ratio, so that should make 10 million moles of, it's a 3-to-1 ratio, isn't it? So that should make 30 million moles of hydrogen. However, there's only a 90% yield, so that would be 27 million moles of hydrogen. And finally, we can do that mass is moles times mR, which is 27 million hydrogen is H2, so times 2, which is 54 tonnes. So the answer should hopefully be 54 tonnes. I should say here, I haven't looked at the answers. I am doing this off the top of my head. And as Ramith pointed out on the last video, I did make a mistake with one of the questions. So do go back and look at the comments there. I'm not infallible. And do let me know if you spot any mistakes I made on this video as well. In the synthesis of ammonia, 56 grams of nitrogen was reacted with excess hydrogen. The mass of ammonia produced was 6 grams. What is the percentage yield? Okay, so we've got 56 grams of nitrogen. Moles is mass over mR. N2 is 28, which is 2 moles. 2 moles of that would be expected to make 4 moles of ammonia because of the 1:2 ratio. So moles of ammonia should be 4, and therefore the mass of ammonia is moles times mR, which equals 4 times NH3 405017, which is 68 grams. Okay, now hopefully I then compare the percentage yield. Percentage yield is actual mass 6 over expected mass 68 times by 100%, and I'm really hoping that I get an answer that corresponds to one of those. 6 divided by 68 times by 100%. Yeah, 8.82 is a valid answer there. And therefore, hopefully, the answer is B. Finally, oh, this was a nasty question. It was badly answered, and it's really, really easy. Because if you look, all of the phosphorus here ends up in this product here. All of this product ends up in this product. All of this ends up in this. All of this ends up in this. In fact, there's only one product. You can actually write it as P4 plus 5O2 plus 6H2O, forming 4H3PO4. So there's only one product. So therefore, it must be 100% atom economy. You didn't need to do anything more complicated than that. And if it does look like a question like this is going to be a huge amount of work for 1 mark, there's probably a trick to it, especially atom economy. Just see if there's anything that has 100% atom economy, especially if that is one of the answers. With the longer answer questions, I think you've seen these before, probably quite recently, but just pointing out the common mistakes. Here, calculate the percentage purity of the sodium hydrocarbonate. Give your answer to 2 significant figures. Pretty much everyone got it. I think this is from memory. It was 90% was the answer. A fair few people giving 90.04%, but that is not to 2 significant figures. The other thing here is that the total error in the gas syringe, just like with a pipette that's got a single line and a volumetric flask that's got a single line, here they are giving you the total error in the gas syringe. So wherever you read it to, they're giving you one reading, and so therefore the percentage error is the actual error, just 0.4 divided by the volume you collected, 58.4 centimeters cubed, times by 100. 0.4 divided by 58.4 times by 100. 0.684 hopefully. Now I suspect many of you doubled that, value thinking that you needed to make 2 measurements, but it does give you the total error. So just watch out for that. 2 small errors that nevertheless would have cost you a couple of marks. Finally here, state the number of moles. Most people were fine with the equation for the titration reaction and the number of moles of sodium hydroxide that reacted and the number of moles of hydrochloric acid that reacted with the sodium hydroxide. I think from memory that the answer was, sorry, let me just change my pointer back to a pen. I think from memory the answer was that the number of moles of sodium hydroxide was 0.614. Okay, now I think a few people recorded that as 0.61 and we'll see why that was a problem. Calculate the mass of hydrochloric acid present in 100 centimetres cubed of cleaner. Right, you're using 25 centimetre cubed portions, so the first thing we need to do to work out the number of moles is 0.614 times by 4, and that gets us the amount that's present in 100 centimetres cubed of cleaner. But then we want the mass, so we need to times the number of moles by 36.5, and if I do that, 0.614 times by 4 times 36.5 gives us 0.964. Sorry, what have I done? Gives 8.96. Right, so that must have been, apologies, 0.061, 0.0614, 0.0614, okay? So 8.96 grams per 100 centimetres cubed, and that was the right answer. Now, if you'd rounded too early, you couldn't get the right answer to 3 significant figures. So if you had 0.061 times 4 times 36.5 and you got the answer 8.91, you are inventing precision because your input data is not accurate to sufficient precision for you to give that correctly. So just watch out for that, okay? If you've asked to give something to 3 sig figs, your input data must be accurate to at least that. Using the technician's results, comment on the validity of the manufacturer's statement that the toilet cleaner contained 9 grams of hydrochloric acid per 100 centimetres cubed. Yeah, of course. If you're only quoting it to 9 grams, then the inherent error is that that is anywhere between 9.5 and 8.5 grams, which of course this is. So it's absolutely fine if it contains 8.96 grams because rounded to the nearest gram, that is 9 grams. So any answer within this range would be 9 grams per 100 centimetres cubed. That's absolutely fine. Explain why titrations involving the use of a 2.5 mole of sodium hydroxide solution would not be advisable in the school or college laboratory. Right, be careful. Harmful was not specific enough, so you couldn't have harmful. Too concentrated. Well, what does that mean? Why is that dangerous? So no. A fair few people still think that acids are toxic. They're not toxic to the body, but what they are, acids and alkalis, they're not toxic, they are corrosive. So the solution is very, very corrosive. And that is why strong acids and alkalis should not be used in the school or college laboratory. I do hope these videos have been useful. Please do subscribe so that I can get over 100 people and get a dedicated YouTube channel by the time you're back. Also, do let me know if you've got any questions, if you don't understand any questions we haven't gone through, if I've made a mistake in my videos, or if there's something specific I haven't covered and you think it'd be useful for me to create a short video for. I've kind of enjoyed doing these. I hope that you haven't found them too painful to listen to, and have a lovely Easter, and I will see you on the other side. Bye.